Hello, David here, and welcome to a tutorial on Omron Robot in Visual Components. When following any tutorial, check the lesson on the Visual Components Academy, and if the Download Files option appears, you can download the example files. For this tutorial, we will enable the Visual Components Connectivity feature. To enable the feature, go to File Options Add-on and use the toggle switch to enable connectivity. Then click OK below and restart the application. And for the robot controller, we are using Omron Ace version 4.7.3. Information on where to download any additional software components will be included in the video description. We are in the Program tab, and we have created a layout to show the Omron Robot plugin. It includes a SCARA robot, i4 550L350, and one 6-axis robot, a Viper 850, from the Omron collection in the eCatalog. If we click play to run the simulation, we have cubes coming from one feeder and empty trays coming from another. The SCARA robot picks the yellow and green cubes and places them into trays, which move on to the next station, where the Viper robot picks up a tray and places it onto the next conveyor. Let's reset the simulation, and selecting the SCARA robot, click on Signals above to check the signals connected to the robot. We have 2 conveyor sensor signals and 3 conveyor power sensor signals. So the output 1 will be used to pick and place the cube from the conveyor to an empty tray. Conveyor sensor 3 and the conveyor sensor will detect the presence of the cube or tray for the robot, which are handled with inputs 101 and 102. And then once the parts are in place, the robot uses one of these signals, 200, 201 or 202, to stop and start the conveyor. Then turning off the signals and selecting the Viper robot and turning signals on again. For the Viper robot, we have an output signal 1 to open and close the gripper. We have a conveyor sensor connected to the robot's input to inform the robot of the presence of a tray with a cube. And we have signal 301 from the robot connected to the conveyor to turn it on and off. So then, closing the signals, let's run the simulation again to see how it looks. The cubes are generated from the feeders, which travel along with the conveyors, and once they reach the sensors, the parts are stopped. And empty trays will be created by this feeder, and once they reach the conveyor sensor here, the trays will be stopped. And the robot picks a cube from one side, places it into a tray, which travels with the cube to the next conveyor. The Viper robot will then pick the tray based on the trigger from the sensor and place it to the next conveyor. Let's reset the simulation and do some post-processing for these robots. Selecting the SCARA robot, and from Post-Process above, under Omron select Download. Let's name the file Station 1, which saves as an omron.pg file. Then click Save and click OK. Note the message in the output panel below, indicating that we should add a break statement if we want to trigger a signal after the motion point is reached. We will see that while we are checking the program later on the ACE side. Then selecting the Viper robot, again from Post-Process, under Omron select Download. Name the file Station2, save the .pg file and click OK. Now we have programs for two stations, station1.pg and station2.pg file. And note that we also have .var files. And now let's see what's included in these PG and var files. The PG file is the actual program file, which converts the statements from visual components. And the var file is the variables file, which includes the targets for the robot. So we need both .pg and .var files. And here in Visual Components, we have the programs, which have been post-processed to .pg files. To test the Omron plugin, we are using ACE version 4.7.3. Before creating a new project, we will enable Open in Emulation mode. Then click to create a new project. Add a project name. The category is Robot Controller, and we will leave the device as Smart Controller, and click Create. Once the project is created, we can expand it, and we see that no robots have been configured yet. To configure a robot, we have to click here to make the controller go online. And now it's connecting to the Smart Controller. Then we can right-click on Robots and select Configure Robots. Now let's choose the robot we used in Visual Components, the SCARA i4 550L 350. So let's click to add it and click Next. And now the robot is added to the controller. Now let's arrange some application panels. We enable the 3D visualizer, and the V+ jog control panel, and arranging the panels so we can see the jog control and the 3D visualizer window side by side. And to execute the robot programs, we need the task status control. Which we will place there. And we can do some more panel rearranging. So now we have one robot for one smart controller, and since in Visual Components we have two robots, we will need two smart controllers here. So let's insert another smart controller and notice that here we now have two smart controllers. And selecting Smart Controller 1, we click here to make the controller go online. And then right-clicking on Robots, select Configure Robots. Select the Viper 850, click to add it, and click Next. So now we have two smart controllers, Smart Controller 0 for our SCARA robot, and Smart Controller 1 for our 6-axis Viper robot. Now let's add the post-processed robot programs from Visual Components to the ACE controller. To do that, let's select the Smart Controller 0 for Station 1 and expand Programming. Then right-click on the V+ modules and select Load from PC File. select the station1.pg file and click Open. Similarly, we have to add the variables. So right-clicking on Variables, select Load from PC File, and change the file format to V plus variable files, 4.var files, and select the station1 var file and click Open. To view the program, expand Station1, and clicking to open Station1, we can see the statements. And similarly, to see the variables, double-click on it, and we can now see all the robot target positions. Let's do the same for our Station 2, which is Smart Controller 1. And now we are using the Viper robot. Right-click on the V Plus modules and select Load from PC File. Select the station2.pg file and click Open. Then to add the variables, right-click on Variables and select Load from PC File. Change the file format to V plus variable files, 4.var files. Select the Station2 var file and click Open. Now let's return to Visual Components and connect the application to the ACE controller. In the Connectivity tab, select Omron and click Add Server above. If you have the ACE controller installed in the default path, then the green File Found indicator should appear on the right. If you have it installed in a different path, then you should change the path. To do that, let's go to our Visual Components Product Installation folder and locate the file called visualcomponents.connectivity.omron.dll.config. Open it with administrator rights in your preferred text editor, and there you can edit the value, which contains the path where you have installed the ACE controller, and the path should point to bin, modules and ACE. Then to connect to the ACE controller, you can enter the host IP address, and then click Test Connection. And when you see the connection succeeded prompt, make sure your controller is running on the ACE side. Then click OK and click Apply in the lower right corner. And now we can connect the server by clicking on the Server Connect Disconnect control. Then to view the controller variables, right-click on Server Dissimulation and select Add Variables. We have two controllers on the Omron side, Smart Controller 0 and 1, which we can expand. Smart Controller 0 is for the SCARA robot, and Smart Controller 1 is for the Viper robot. Let's now map the joint variables. So with the Server Dissimulation selected, we will first select the SCARA robot and enable the Only Selected Components option, so we have a filter for only the SCARA robot. Then searching using value, we can see J1, J2, J3 and J4 joint values. Then expanding the SCARA robot folder, under the Smart Controller 0 on the right, expand the joint folder. Then holding the Control key, select one by one the joint values from the simulation side. And then on the ACE server side, holding the Shift key, select all joints JT1 to JT4 by selecting the first and last item, and then click Pair Selected. Check that J1, J2, J3 and J4 are mapped correctly. Then selecting the Viper robot and collapsing the SCARA robot folder, expand the Smart Controller 1, Viper robot and joint folders. Then holding Control, select the joint values from the simulation side, and from the ACE server side, holding the Shift key, select all joints JT1 to JT6 and click Pair Selected, and check that JT1 to JT6 are mapped correctly. Let's now configure the output signals from the ACE controller to visual components. So we are controlling the conveyor's base controller, so let's first focus on Station 1. Selecting the Station 1 tray conveyor and expanding the Smart Controller 0, I/O and output folders, we will be using output signal 202 to control the conveyor. So then searching using 202, select output 202 and expanding the Station 1 tray conveyor on the left, select the power on signal to map it directly and click Pair Selected. Then selecting the Station 1 green cube conveyor, where we will be using output signal 201, selecting output 201, we will expand the Station 1 green cube conveyor and again select the power on signal and click Pair Selected. And for output signal 200, selecting output 200 and selecting the Station 1 yellow cube conveyor, again select the power on signal and click Pair Selected. And then selecting the Station 2 out conveyor, we will be using the Smart Controller 1 signal 301. So selecting output 301, select the power on signal and click Pair Selected. After mapping the server to simulation variables, let's now map the simulation to server variables. Right-click on Simulation to Server and select Add Variables. Here the inputs from the simulation to server are the sensors. So then selecting the Station 1 tray conveyor sensor, which detects the presence of the part from the simulation environment. Then expanding the Station 1 tray conveyor sensor, select the sensor Boolean signal, and expanding the Smart Controller 0, I/O and input folders, map it to the input of the Smart Controller 0, 1001, and click Pair Selected. Let's then select the Station 1 cube conveyor sensor, and expanding it, select the sensor Boolean signal and map it to input 1002 and click Pair Selected. To detect the presence of the tray in Station 2, let's select the Station 2 tray conveyor sensor and expanding it, select the sensor Boolean signal. And now we need to map the input to the Smart Controller 1. So then expanding the Smart Controller 1, I/O and input folders, select input 1001 and click Pair Selected. We can now close the Create Variable Pairs panel. So now our server to simulation and simulation to server variable pairing should look like this in the Connected Variables panel. Before starting the simulation, we need to add a break statement in the generated program. To view the generated program on different controllers, we can select the Smart Controller, and here of course we have two Smart Controllers. Then under the V+ modules, we will have the robot program. If we take a closer look on the Station 2 program under Smart Controller 1, note that in this section of the video, we will refer to the Viper robot picking, placing and waiting for a box. It is still a tray of course. In this case, we just used the term box when creating the program routines. So we are waiting for the box, we are picking the box, and then we are placing the box. If we go to the pick box routine, we added the break statement manually here, because in the ACE robot controller, V+ executes motion control statements immediately and does not wait for motion to complete before continuing to the next statement. This forward processing is the normal method for basic motion control operations. So in this case, we are using signal 1 to pick the box, and we are adding a break statement so that the robot reaches the picking position and then executes the signal 1 to be true so that the box is picked. And in the place box routine, we add the break statement. at the point where the robot drops the box. And then we trigger a signal -1 for the gripper to open and release the box. This is the same for the other transport controller robot program under Smart Controller 0. For example, if we go to Place Cube, we can see the same break statements here. The robot programs are executed in the ACE controller using the Task Manager. So we can see from the Task Status Control both smart controllers and the Task Manager for each smart controller. So to have more screen space, let's close the V+ drag control panel. Then let's drag the Task Status Control panel upwards, and selecting the Task Manager for Smart Controller 0, which is for Station 1, we will use Task 0 and select Execute Task, and then select the program we want to execute and click OK. As you can see, the robot is now waiting for the tray. Then selecting the Task Manager for Smart Controller 1, which is for Station 2, use Task 0 and select Execute Task. Select the program to execute and click OK. And now the robot is waiting for the box. Let's now return to Visual Components and run the simulation. Before starting the simulation in Visual Components, let's disable the executor for the robots in their Properties panels on the right. Then to create some more screen space, we can use the pushpin control to hide the connectivity configuration and component properties panels. And now let's click play to run the simulation. And switching over to the ACE environment, we can also see the robot programs being executed. So now the connection works and everything seems to be working as expected. Excellent. And this concludes the lesson. Thank you for watching.